Welcome to Space News from the Electric Universe, brought to you by the Thunderboltsproject at thunderbolts.info. According to a paper in the journal Nature, astronomers are now looking for a whole new theory to explain how planets form. The standard model of planet formation says that planets and stars form gravitationally in a contracting disk of gas and dust, called the core accretion theory. Since astronomers believe that this model explains our solar system, they expected that exoplanet systems would play by the same rules. However, astronomers have now observed countless baffling systems that cannot be explained by conventional reasoning. According to astronomer Gregory Laughlin, the core accretion theory has led to no success in extrapolating what's out there. While astronomers now admit they have no idea how these exoplanets form, they still express confidence in their understanding of our own solar system's origins. However, as Wal Thornhill explains, this confidence may be badly misplaced.
A Nature article on the 3rd of July this year says the discovery of thousands of star systems wildly different from our own has demolished ideas about how planets form. Astronomers are searching for a whole new theory. That would be a first, because in the past, the new findings have always been tied back to the original theory. In fact, it's quite surprising how strongly attached we are to these stories about how the universe was formed in a Big Bang and how the solar system was formed from a disk of dust and gas. It's actually centuries old, and no one has thought to throw the whole thing out and start again. The story is based, of course, on the very extremely weak force of gravity and the idea that somehow or another you can have material spiral inwards to form a star, and then the leftovers would form the planets. But there is no good explanation for how you reduce the rotation of matter. Some energy has to be exchanged in order to do that. So once again, the astronomers invoked magnetic fields to form some kind of magnetic braking. But here we find, as more and more information about planets around other stars comes in, we find that those planets don't conform to the theory of planets forming in a disk about their central star. Some of these planets orbit extremely close to their star, some orbit in retrograde orbits, some orbit about the poles, and in some cases, the planets in orbits that are very close together actually have quite different compositions, which flies in the face of the idea that our solar system was formed from material which was graded in properties as you move outwards from the sun. In fact, our treasured theory of formation from a disk of dust and gas has faced huge problems before the exoplanets added to them, because no one has been able to say how Neptune was formed at that great distance from the sun. It hasn't had time in the 4.5 billion years traditionally assigned to the age of the solar system for that planet to actually form. What's more, we have all kinds of anomalies with the inner planets. In fact, the planetary system is a complete fruit salad. You have planets with properties that vary quite strongly. They have surfaces which exhibit different features. If the same events were occurring on all of the planets during their evolution, you would expect there to be some similarity between Venus, Earth, and Mars. There are none. Mars is much smaller than you would expect on the theory. It should have had more water, more of the lighter elements trapped at that distance from the sun. And yet the Earth has a huge amount of water. Venus has a huge amount of carbon dioxide. And Venus is almost hot enough to melt lead. So the whole picture has never been a very good one, right from the beginning. The means used for detecting planets about nearby stars has, in the early days, detected the large planets orbiting their central star more closely than Jupiter. Consequently, it seemed that there was a huge puzzle right from the very beginning, because here we found hot Jupiters, as they're called, orbiting their central star in a few days or even a few hours in some instances. They are so close that there is no way that they could have formed at that distance from the star, given the gravitational accretion hypothesis. The electric universe paints a completely different picture, and what's more, it's been confirmed by recent infrared telescope results looking into molecular clouds where stars are formed. And they have found that stars are formed along thin channels which are lit up, and the stars have been called beads along a string. So stars are not formed by gravitational accretion from a cloud, they are formed along cosmic lightning bolts. Now, the telescopes can only pick up the largest bodies, which are the stars, but those same cosmic lightning bolts are quite capable of forming the so-called hot Jupiters along that same channel. So the very fact that we find stars with close orbiting hot Jupiters is no surprise at all in the electric universe model. The other aspect of the electric universe is that it shows that the gravitational force is modified by the electrical nature of the body, so that if a body is charged more or less than those around it, there will be charge exchange, and in the process, gravity will modify the orbits of those bodies. The result is that capture is far more likely in the electric universe than in the gravitational model. So the fact that we have so many binary stars and odd planetary systems is no surprise at all, because if you're capturing a body that's coming in from some angle nearby, it can rotate in the opposite direction, it can rotate about the poles, and these are the kinds of things that are being found. Inexplicable in gravitational theory, they are perfectly reasonable in the electric universe.
Scientists' ideas about star formation were given an additional jolt in February of this year. Astrophysicists using the sub-millimeter array telescope obtained the most detailed images to date of a stellar nursery. They discovered that the star-forming regions, called cosmic seeds, weighed only a fraction of the predicted mass necessary to give birth to high-mass stars. Why is this discovery so significant for the electric universe theory of star and planet formation?
Another serious failure of the gravitational model of the formation of stars and planets is the discovery in a molecular cloud that there was only 5 to 20% of the amount of matter required, or the density of matter required to form a star and planets. Now, the electric universe has shown also that the accretion force around these cosmic lightning bolts within these molecular clouds stretches way beyond the gravitational force and is stronger much further out. In fact, as we all know, the gravitational force falls off as 1 over r squared, the distance to the matter from the central object. In the electric universe, the electromagnetic force falls over as 1 over the square root of r, so it's far more powerful and far-reaching than gravity. So there is no problem at all forming stars as observed in matter, which is only 5 to 20% of the density required. As I said in the previous space news about asteroids and the electric charge that may be found on them, asteroids and comets are not formed according to this gravitational disk model of the formation of the solar system. So any examination of comets or asteroids is not going to tell us about the birth of the solar system. It may tell us something about the recent history of the solar system. And that is simply because during the capture process, a star capturing a large body, a planet or a system of planets around another star, will cause chaotic rearrangement initially of all of those bodies. And that chaos involves electrical interchanges between those bodies. And those cosmic thunderbolts are the very thing which rips material from the surface of a planet or even a substellar body and hurls it into space to form debris of all sorts, ranging from dust through to meteoroids, to comets and asteroids. And even, it can be said, new moons and planets.